first. So when you made y the subject, the first thing you have to do is take the positive 2x, throw it across, and of course you will get what? Negative 2x. So this is what you're supposed to have. 16 minus 2x. Now remember, you cannot subtract 16 and 2x, right? Because one has x and well, the other does not. So you have to leave them separate. But we're not finished. We still have to make who the subject? Y. We have 4y here. So this 4 is a multiply. So when you throw it across, you have two items waiting on this side. You could draw one big divide sign and put the 4 underneath. Or, right, I mean, that's mathematically correct. But doesn't this mean everyone over here is going to get divided by 4 anyway? So why not just save time and put a divide by 4 here and a divide by 4? Both of them are going to get divided by 4. So if we do that now, we're going to get something reasonable, I think. 16 divided by 4 is 4. And 2 divided by 4 is a half, or you could put 0.5 and then put the letter what? X. And nothing is wrong with a decimal, right? So how much people had up to here? Well, when they made y the subject, they basically had that. I know some people would have a half. They would have put the fraction instead. Oh, obviously, that's just as correct. Yeah. Right. Now it's time to choose your values for x. Now you have to be reasonable once more. You have to choose something between 0 and 9 because your x-axis is going from 0 to 9. I'm just going to choose 0. I know that's going to work. I'm going to choose 2 and I'm going to choose 4. I think those are reasonable values to choose because they're between 0 and 9. Great. So calculate your corresponding values for y, right? If you haven't chosen your values as yet, I think it has steal mine. Answers coming. For example, right, if you're trying to calculate this value of y, you have to pretend x is how much? 0. So you just go to the equation here and you throw away the x and in brackets you put 0, right? 0.5 by 0 is 0. 4 minus 0 is still what? 4. And then you do the same thing. You replace the x with 2, then you replace it with 4. Super, super easy, right? And seeing correct answers coming up on the chart, which is good. Right? So if you do back the same calculation and you put 2 here, 0.5 multiplied by 2 is 1. 4 minus 1 is 3. And then if we have 4 minus 0.5 and replace the x this time with 4, 0.5 multiplied by 4 is 2. 4 minus 2 is 2. So you're supposed to get 4, 3, and 2. So you just need to plot these points, and then you have to figure out which side of the graph to shade, which is the wanted side. Well, what is the side we actually want to keep? I made a slight mistake when I drew my graph, right? So I want some people already are going to be able to pinpoint the mistake here. Now I'm sure this is the shape of the graph, right? So I hope you all got something like this. If you look at it, I have the point 0, 4 here, 2, 3 here. Look at it, I have my points here. And I have this, well, I choose a better color here. And 4, 2. 4, 2, right? So I have all my points, right? Right. So the mistake I made, remember last week I told you whenever it's more than or less than, it's supposed to be a dashed line. I drew a solid line by mistake. So this is really supposed to be what? A dashed line. So where do we shade now? Do we shade above the line or do we shade below the line to complete the question? Some people got it wrong. Look at the inequality. You have to look at the inequality when you made y the subject. You're not looking up here Only after you make y the subject, then look at the inequality. You are seeing a more than. Remember last week I told you, whenever you hear the phrase more than, I want you to associate above. So you're already supposed to shade above the line. So you draw little slanted lines like this using your ruler. Okay. Right. And now just to be a little specific, the actual name of the line, I know I mentioned this last week, right? The actual name of the line is y is equal to 4 minus 0.5x. That's this equation. But when you're writing the name of the actual line, you just put an equal sign. The shaded region, the region that we want, this entire region, that is when you put the inequality sign, right? So there's a slight difference, right? The examiner will look at things like that, right? If he asks you for the name of the line, you have to use the equal sign. If he asks you for the name of the region that you shaded out, you have to use the inequality sign, right? So make sure everyone put this and put this, right? That could be the difference between gaining a mark or losing a mark in the exam, right? It has to be a dashed line also, but I don't have the program on me to change it to a dashed line. But you need to change it to a dashed line on your end. Move on. Right. So here's some stuff that we did over the holidays. I just want to refresh your memory. Just now, I think we just drew a slightly complex graph, meaning that the graph we just drew had X and Y in it. But sometimes the examiner will ask you to draw a graph. Look how simple part A is looking. They are asking you to draw the line X is equal to 2. It only has one type of letter. It doesn't even have a Y. Whenever you see questions like this in the exam, smile, because it's an easy mark you will get. The line X equal to 2 requires no calculation. Let me draw it on the graph here for you. It's just a vertical line going through what? 2 on the x-axis. Remember, this is the x-axis here, right? And this is the y-axis. So this line over here that we just drew is a vertical line going through 2 on the x-axis. You can't ask for anything simpler than that. Do you all think you could draw this and then draw part B for me? If x equal to 2 is a vertical line going through 2, what would the line x equal to minus 1 look like? That's also a question you should smile at. Right? Super easy, right? So I'll give you 20 seconds to draw up your little graph there and, draw in the answer. All right, so let's see what this line looks like. X is equal to minus 1. Did you all get this? That blue line, did you all draw a vertical line going through minus 1 on the x-axis, right? So people are saying yes. Right, you get a measly 1 mark for that in the exam, but 1 mark nevertheless. So if you have one letter and that one letter happens to be X equal to a certain number, it's just vertical lines. So by now, I think everyone will be able to get our part C. If you have Y is equal to 3, then it's going to be the opposite. Instead of it being a vertical line going through 3, it's going to be what? A horizontal line going through 3. Right? So you will get this. That's the green line there. It's a horizontal line going through 3. And I'm pretty sure you all can get out part D, right? So draw in part D and I'll just show you my answer. And when you finish, make sure and take down the notes. The note is exactly what we just discussed. Right, so Just to clarify, this here is the answer for part D. A horizontal line going through 2 on the y-axis, right? Another easy question. Right. So you go in the exam and they ask you to draw this graph here. X is less than or equal to what? 40. Like how you're going to draw and shade that? Because it's an inequality, so it has some shading involved. Quick question, is this supposed to be a solid line or a dashed line? Right, it's supposed to be a solid line, right? And when we draw it, or when it's time to draw it, we just have to pretend this is an equal sign. So tell me from your notes, are we going to draw a perfectly vertical line or a perfectly horizontal line? Right, and everybody is getting it correct. Remember, x equal to something is a vertical line going through that something. So when we draw this, how much of you are imagining that? It was a vertical line going through 40. Great. So everyone take down up to there. But we still have to shade the correct side of the line. We have to either shade the left-hand side or the right-hand side. But last week I showed you that. I'm sorry, I didn't show you it. I gave you a note on it. Look back in the notes, and anytime it's a vertical line and it's a less than, do we shade on the left-hand side of the line or the right-hand side of the line, which is the wanted region? Right. I think last week I asked you to associate the word less than. Less than can be associated with below, but if there's no below, you can associate it with left. So that means in the exam, you will have to shade out the left-hand side of the line, just like how I have it here, right? Right. So this is the region here. X is less than or equal to 40. And the actual line itself is X is equal to 40. Remember I said for the actual line, we have to use an equal sign. For the region, we have to use the inequality. Right. How much of you all forgot it was a dash line? To be honest, it is a vertical line going through 10, but I tried to distract you, right? It's supposed to be a dashed line, right? And with, okay, everybody's telling me they did not fall for it. All right. So are we shading the left-hand side or the right-hand side? The right-hand side, because this time it's more than. Remember I told you more than, you can associate it with what? Above. But if there's no above, because in a vertical line, you have no above, is either left or right. You can associate it with the word right. Okay? So you can just shade out the right-hand side like this, right? Once again, just to make sure, the name of the actual line is X is equal to 10. The name of the region is X is more than 10. Right, so take a 10 seconds there and we will move on to the next question. Let's move on. All right. So I think you all can more than handle these two. This time is what now? Y is more or less than something. And you know the Y is the what? Horizontal lines. You just have to draw the line and then make a decision whether you're shading above or you're shading below. We know more than is above. Anything with the words less than is below. And try to get the type of line correct, whether it's a solid line or a dashed line. Right? I'll correct both at once in about a minute. For the first one, we know it's a horizontal line going through 30, but it's supposed to be a dashed line. And since it's more than, you're shading how? Above the line. Okay? All right, so I suspect most people got that correct. For the second one, it's supposed to be going through 45. Now, 45 is in between 40 and 50, and it's a solid line, and it's less than. So I know we have to shade where? Below. All right. All right. So I suspect everyone got it correct. Right. So take 20 seconds and we're moving on. All right. So let's look at this, right? Don't draw the answer. This is the answer to the question, right? Let's say, right, that on the same graph paper, they ask you to draw 3 inequalities. So they give you 1 inequality and you have to draw it. Then you draw the next inequality. So you draw it and then you draw the third one. If you notice on the graph here, well, we're going to draw each of them individually, right? So I want everyone to take down the first equation. And I want you all to draw that inequality for me, right? Of course, you don't know which one is which one here, right? So let's focus on that inequality there. Y is less than or equal to 80 minus 2x. You'll have to draw up a little table like this in the exam, using one graph for this to fit all 3 in. You have x and y. Notice my x-axis is going from 0 to 60. So you have to make sure and choose things between what? 0 and 60. Draw it for me and tell me which one is that line. Is it the green line? Is it the purple line? Or is it the black line for the first equation? Right, so when we're doing the calculations, when we put 10 here, 2 by 10 is 20. 80 minus 20 is what? 60. When we choose 20, 2 by 20 is 40. 80 minus 40 is 40. And when we put 30 here, 2 by 30 is 60. 80 minus 60 is 20. I think that's the purple line, right? Look at it. 10. That's not what, no, that's not the purple line. That's the green line. Look at that. It's the green line. Right. It's 10 and we have 60 here. 10, 60 is up here. If you look at it, right. Next point is 20, 40. 20, 40. And the next point is 30, 20, which is over here. All right. So it's the green line. Get started with drawing the next line. Now, the next line is going to give you the purple line, obviously, right? Because we know that the black line is this equation over here. Right? So you draw up a little chart like this, X and Y. You can probably just choose what, 0, 10, and 20. That should be good enough, right? Now I'm building up to something, right? I'm just not making it draw 3 graphs on the same graph paper for no reason, right? There's a point to it. When you choose the 0, we get in, well, 2 by 0 is 0 plus 10. So we get in 10 here. When we choose 10, 2 by 10 is 20. 20 plus 10 is 30. And when we choose 20, 2 by 20 is 40, 40 plus 10 is 50. That's definitely what? 0, 10 is here, 10, 30 is here. So it's definitely what? The purple line. Right, oops, sorry about that. Right. So the question is now, right? You could draw in the third line over here, the black one, right? The question is now, well, whenever you have more than one graphs on the same graph paper, where do we shade, right? There's something called a common region. I'm going to try to explain what a common region is using different colors. You all ever use different paints, and when 2 paints overlap, you just get a different color. For example, white and red. If you take red paint and you put white paint on top of it, you get a different color. Well, what's a different color? When you mix white and red, it's pink, right? And of course, it have different colors, right? Like I believe, let me see if I get this correct. If you use blue and red, when you combine blue and red, if they overlap, you get purple, right? So here's the thing with this question, right? I need to clear the screen here because it's going to get a bit confusing. You see, if you look at each graph individually, like this graph here, right? Let me see if I get the correct colors. We said this graph was the green graph, so I'll use green. This graph, when we were drawing it, it was a less than. So what would happen if you paid attention to the green one only? Since it's less than, you would shade below that graph, right? I don't want to get too complex, but you would shade below in this direction of the green graph. For the purple graph, which is this one, I don't have purple, so I'll use blue. He was also what? A less than. So for this one, you would also shade below. So you would shade this way. For the black graph, since it was a less than, you would shade where? Below that line. So here's what I want you to pretend. I have a program to show you after in more detail. If for the green line, you shade everything below in green, and for the blue line, you shade everything in blue, and for the black line, you shade everything below in black. Won't it have one region where all the colors overlap, where all three colors overlap? Would it be over here in area A? What do you all think? Would it be in area A? The answer would be no, right? Because this area has no black in it, because all the black going what? Below the line. So it is kind of hard to imagine, right? So let me use a little program I have here. And this is a free program you all can find on the internet. It's called Desmos, where you'll see it on the screen. Right. Oops. Right. Let's see. Right. It's called DESMOS graphing calculator. It's real useful. So let me start back to draw back all the graphs. All you have to do is type in the equation like this. Y is equal, I'm using the equal sign for the time being, 80 minus 2x. And it will automatically draw the graph for you. It's pretty cool, right? Let me put in the next equation. The next equation was y was equal to 2x plus 10. And it drew the other graph for me. And the other graph was what? Y is equal to what? 20. But they have it in green here, right? But you can easily change the color and thing, right? It's really easy to change the color. Well, not too easy right now, but I guarantee you it's easy, right? So let's see where we can, I just need to make the graph a little bit bigger, so you all just bear with me for a little bit, right? The x-axis is going to, right, so I think you all can see it a little bit better there. Right, they're looking a little bit better there, guys. You all can see everything clear there now. Right. So for this graph over here, I don't know why the little writing is so small right now. For the red graph, right, are we shading below or above? Do you all remember? It was a less than, right? So I'm going to put in the less than symbol here for you all. Less than or equal. You notice what it did? It shaded everything underneath that graph in what? In red. For the blue graph, let's shade underneath that graph in blue. So it shaded everything underneath the graph in blue. And for this graph over here, the last graph, he was also a less than. And you notice now, where does all the colors overlap? In which area has all three colors? Is it area A, B, C, D, E, or F? Where has all three colors? Look at, somebody had it wrong, right? It's not C, it's not C. It's area what? E. Look at it. Over here has red, over here has the blue, and over here has the green, or all three colors, right? So it's take a little bit of imagination in the exam, right? To figure out where to shade, right? So where do we have to shade? Region E. So how are you going to do that in the exam? Right, let's go over here, U, right? So region E was this region here, from here to here to here to here. It's a kind of weird looking what? Trapezium. It's not a full trapezium. It's a weird looking trapezium. You just have to shade that region, because that region will have all three colors. Because once again, you're shading below the green line, you're shading below the purple line, and you're shading below what? The black line. The only place that's going to have all three colors overlapping is this region here. Not here. Here will have no green in it. Think about it. All the green going this way. No green is going in this area. Right? So a lot of people must be asking, well, how you can use this in real life. Why am I drawing lines and then shading it out like a mad person? How can this be used in real life? But I have good news. This is one thing you might actually use in maths in real life. You can use it in business. For example, right? Everybody wants to make the most amount of profit in a business. Think about it, right? That's the aim of a business, to make profit. Now, every business has limitations. In other words, nothing is perfect. You know, you have some people like when they go, like let me say they're selling hot dogs, right? I used to have a friend like this, right? So they were going into, was it hot dogs? I can't remember what they were going to sell. They used to go like this, right? Okay, I'm gonna sell hot dogs. I'm gonna be real rich. Every day, I'm gonna try to sell 2,000 hot dogs. Tell me if that's realistic. It all depends on your location, right? I mean, if you're in a big event, like in a fete or something, and you have a hot dog stand, well, I can see 2,000 hot dogs probably selling. But if you are selling hot dogs on the side, outside your house, like you now start out the business, so you go on the pavement and you put up a hot dog stand, most likely you're not going to be able to sell 2,000 hot dogs on one day for many reasons. One, on your particular street, it might not have 2,000 people passing on a daily basis. So that's what you call a limitation. Also, you might not have what? Refrigeration facilities. So to store the hot dogs, you're going to have to use what? Coolers. And 2,000 hot dogs might not be able to fit in the coolers. You might only get what? 50 of the hot dogs to fit. So you have to consider all of those things in a business. And we're going to look at an actual business right now, right? So I think that's the next slide. And you'll see where I'm coming from. Oh, by the way, here's the shaded region. I forgot to put in the answer. So here's our business model, right? We are going to set up a business where we sell two things, the two yummiest things on the planet: hamburgers and ice cream, right? So after you eat your hamburger, you can enjoy some desserts, okay? Let's look at the profit, right? First of all, when we did the maths, the profit on each hamburger we sell, we're only going to make $3, right? That's profit, pure profit. And for each ice cream cone that we sell, we're going to make a profit of $4. We're going to let the letter X represent hamburgers. The letter Y represent what? Ice cream. And look at the conditions. For some reason, we must not sell more than 60 hamburgers. And there must be a good reason for this. Maybe our supplier has only 60 hamburgers to give us, or maybe the cooler we have assigned to the hamburgers could only hold how much? 60. But the point is, whatever our circumstances are, we realize that we cannot sell more than 60. And for our business to be profitable, we must sell more, at least 10 a day. Now, let me explain why sometimes you have to sell over a certain amount in order to stay in business. Whenever you're buying from suppliers, right? For you to be sold to, you have to prove to your supplier that you could sell a certain amount a day. Otherwise, they will not waste time delivering the ice cream to you. For those of you who are in business, who parents in business probably know about that, right? Well, when I now started to sell like chocolate bars and whatnot, that's a long time ago. The company would not supply me with chocolate bars unless I could guarantee to them that I would sell a certain amount every day. Otherwise, it just wasn't worth it for them to deliver chocolate bars to me to sell. And here's the thing. You also have a cart, a real nice, fancy looking cart here. And of course, this is a small cart. It only has space for 80 food items. So that means when you add up all the hamburgers and add up all the ice cream, the total must come up to 80. That's all the space you have. Everyone take down everything on the screen, and we're going to figure out how much hamburgers we have to sell every day and how much ice cream we're going to try to sell every day in order to make maximum profit, right? Let me know when you're finished. So what the examiner will do afterwards, right? After he describes the situation, and I have just described the situation, except I use nice pictures and whatnot, right? In CXC, they're not going to use nice pictures. There's going to be a paragraph, right? They're going to ask us to come up with 3 inequalities for this particular scenario. Do you think we could come up with an equation? Let me help you with this one, so you get an idea. Remember, the letter X is being used to represent hamburgers, and we must not sell more than 60. Tell me if this is correct. We must not sell more than 60. How much of you all agree with that? Nah, you should not agree with me there. This is where English comes into play. English is a funny language, right? Look at what they said. You must not sell more than 60. So you hear the word more than. So when you hear the word more than, well, your mind is going to what? Put a more than sign, right? That's how most people's brains work, right? That's how mine used to work, right? Right. But let's think about this. Say I walk up to you and say, you must give me, sorry, you must not give me more than $60. So I am telling you to not give me more than $60. Is it okay to give me $61? I ask you to not give me more than 60. Right, it's not okay. In fact, this sentence is saying that you should give me $60 or less. Think about it, right? I ask you to not give me more than 60. So it's okay to give me exactly 60, or you could give me 59, 58, 57. So this is actually this inequality, less than or equal to 60. because they said not more than 60. You can't forget the word not. So so X has to be less than or equal to 60. So don't let these words tie up. These are little buzzwords when you hear the word more. So you put a more than sign, but they said not more. So it's the opposite that they're asking for. How about this one? You want to send the equation for this one? I am telling you, you must sell at least 10 every day. The letter Y is being used to represent ice cream. What equation would we get there? Right. Is it okay to sell 11? If you sell 11, will you be okay in that scenario? Right, because I am telling you, you must sell at least 10. So if I want at least $10, that means it's okay to give me $10, $11, $12. In other words, more than or equal to 10. Okay? So here, the word least actually ended up being a more than sign. When you're ready, think about the situation. English is funny, in my opinion. Right? So that's the second inequality. The third inequality, think about it. The cart only has space for 80 food items. Isn't X the amount of hamburgers you plan to have? Isn't Y represents the amount of ice cream that you plan to have? So if you add them up and you only have space for 80, then the total amount of items has to be less than or equal to 80. Because if you add up all of them and you get more than 80, then some of the items will simply not fit in your blue cart over there, right? Not X multiplier. When you add up all the hamburgers and you add up all the ice creams, keyword, add them up. You have to make sure they all total up together to be what? 80, right? Now, here's the thing, right? A lot of people will say, here what? If I only have space for 80 items, then why don't I just always try to sell 40 hamburgers and what? 40 ice cream. Doesn't that sound logical? But the truth is, you could do that, but that might not what? Bring you maximum profit, right? For all you know, a different combination will be better. 40 plus 40 is 80, but isn't 20 plus 60? For all you know, if you attempt to sell 60 ice creams instead and 20 hamburgers, you might come out with a larger profit. But it have an infinite, not it have a lot of combinations. You could sell 10 of him, 70 of him. You could sell 35 of him, and I shall use an easier number. Let's put 30 and 50. But you simply don't know what is the best what combination. And linear programming, the part where we shading and whatnot, helps you to figure out the correct combination based on all the conditions specified in the question, right? So everyone make sure and have all three equations. We're going to try to draw all three on the same graph paper. And then we have to figure out which area to shade. Let me know when you're ready to move on. Let's move on. Let's see. All right, so sorry about that. All right, so let's start off with the hardest equation. The last equation was x plus y is less than or equal to what? 80. Do you all think you all could draw this line for me? Make sure and make who the subject? Y. But that's easy. Let's draw across positive x to get what? Minus x. You choose your three values for x, calculate your values for y, draw the graph, and then I will show you my graph. When I chose 10, well, it is replacing here with 10, right? 80 minus 10 is 70. If we replace it with 30, 80 minus 30 is 50. And if you replace it with 50, 80 minus 50 is 30. Right, so those are my three values. You just plot it on the graph, use a ruler, you know the drill. Right. So you'll let me know if you got something like that. Well, it's the green line, right? I already have the other two lines were pretty easy, right? But because I believe the other two lines was what? X is less than or equal to 60 and Y is more than or equal to 10. So the green line is this one here. I'll label it for you guys just now. The actual lines itself. This one here is X plus Y is equal to 80. This one here, the vertical line going through 60 was X is equal to 60. And this horizontal line going through 10 is Y is equal to 10. Right? Make sure you understand it, then draw it, and make sure your green line is exactly like my line, right? So we're trying to figure out where to shade, right? So for this one here, remember, it was really a less than or equal to. So if it's less than or equal to, remember it was less than, we have to shade below the line. So this green line, everything underneath here will get shaded, pretend it's in green. For the vertical line, you notice it was a less than. For vertical lines, if it's less than, you shade to where? The left of the line. So we have some shading, some purple shading coming this way. But for the horizontal line, it was a more than. So we shaded over here, above. Now, a lot of people said G, but does G have any purple paint? Look at it. This is the purple line, and we are shading this way. G does not have any purple paint. So G is not the answer, right? So definitely anything on this side, it can't be C, it can't be G, it can't be E, it can't be D, because none of these regions will have purple because the purple brush going this way. So it's B, and it cannot be F because, and we going above this line. So below this line will have no black paint. So F is out. So it's between A and B. So which one do you think is the correct one? It has to be A because B has no green paint. Look at it. And you're painting below this line green. So how he getting any green, right? So it has to be what? A. A is the common region, right? Let me see if I have it here. Right, so when you shade it, it will look like that. It's region A. That is the region that we want, right? Right, so everyone make sure and shade it, right? I'm gonna see something in the next. I just need some space over here, so I have to erase this. All right. Right. So when you finish there, will we not finish with the question? We have to figure out how much hamburgers and how much ice creams to sell in order to make the maximum profit. All we did so far was draw the three graphs and figure out where to shade. We still have not answered the question of how much to sell of each item. Help me out here, guys. Remember when we now started the question, do you all remember the profit on each hamburger? Remember, the x-axis is being represented as the hamburgers and the y-axis is represented as ice cream. Well, what was the profit on each hamburger again? $3. All right, so for the hamburgers, I'll put H for hamburgers. The profit was $3. And for the ice cream cones, what was the profit? I'll put 50, so this will be 3. It was $4. All right, great. I really couldn't remember. So let's build a profit equation. How would you calculate profit? Tell me if this equation makes sense. If X is being used to represent hamburgers and Y is used to represent ice creams, the total profit is 3X plus 4Y. Because for each hamburger that we sell, and X is representing the amount of hamburgers we make in $3. And Y is representing the amount of ice creams. So if we multiply by 4, we will get the total profit for all the ice creams. And of course, if we add up both of them, we get the total profit for the day. Does that equation make sense? It will literally be that simple to create the equation in the exam. They'll give you the profit of one item, the profit of the other item. Great. So to calculate the profit now, we just need some values for X and some values for Y. Where are we going to get those values? Very, very simple. Okay. I just have to erase the equations over here because I need the space, right? So I'm going to erase him. All you have to do now is pay attention to the shaded region. You will notice your shaded region has corners. One corner here. I'm going to get a better color. One corner here. One corner here. One corner, and well, one corner here. So this shaded region just happens to have 4 corners. It is called them vertices, corners. And that's the official mathematical name is vertices. I'm going to call this point A. I'm going to call this point B, C, and the last one D. Obviously, in the exam, you could call it any letters you want. Do you all think you all can get the coordinates of point A, the coordinates of point B, and of point C, and of course, point D? Make sure and put the X and then the Y, the X and then the Y. Tell me, compare the answers just now. Let's see. I'm getting 0.80 here. I have to put the X and then the Y. Point B looking like 60, 20. Right. Point C looking like 60, 10. And the last point looking like 0, 10. So you're only taking the vertices. You don't take any other points. And here's what you have to do now. You have to take point A values and you go to the profit equation. So for point A, X is what? 0 and Y is what? 80. So you go to the profit equation. You replace X with 0 because that is what that point says. And you replace the Y with 80. And you work out the profit. So the profit for A is 3 by 0 is 0 plus 4 by 80 is 320. So the profit for point A is how much? $320. So if we sell 0 hamburgers and sell 80 ice creams, this is how much profit we will come out with. Do the same thing for point B. Do the same thing for point C and D. And see which one gives you the largest profit. And of course, the one with the largest profit is the one we're going to choose for our business. That is what we're going to aim to sell for our business. All right, so let me work this out. 3 by 60 plus 4 by 20. Oh, we get 260 here. I guess you all probably are correct. So we gain 260 here. What we gain here? 3 by 60 plus 40. 220. And the last one, you all can agree with these values? So apparently, for this business, based on the highest profit is point A, which means we should attempt to sell no burgers and only focus on ice creams. So someone said we should just change it to ice cream business and done. Right? So I guess in burgers is not about up our alley for business. All right.